For decades, quantum technology has kind of felt like something straight out of science fiction, right? Redefining computing, communication, our whole understanding of reality. But the thing is, what was once just stuck in research labs is now starting to break out. We are right on the verge of a monumental shift. And in this explainer, we're going to break down exactly what that means for 2025 and beyond. And look, this isn't just hype. A 2025 report from MIT basically says it all. Quantum is moving from just a cool theory to something tangible, something with real commercial promise. And this shift, it's kicking off a huge global race for leadership in what a lot of people are calling the second quantum revolution. So, that's the big question, isn't it? Is the quantum future actually here? And if so, who's out in front? To figure that out, we're going to follow the trail. We'll look at the innovation, the investment, and the big national strategies that are being deployed to try and win this technological arms race. Okay, first things first. To really get where we are now, we have to understand this idea of a second quantum revolution. You hear that term thrown around a lot, but the difference between the first and the second revolution is, well, it's everything. It's what makes today's development so incredibly transformative. This slide really just lays it all out perfectly. The first revolution was about observing quantum mechanics. It gave us awesome stuff like lasers and the transistors in your phone. We were using the effects. But this second revolution, it's all about direct control. We're now engineering reality at its most fundamental level. Manipulating individual qubits, harnessing wild stuff like entanglement. We're not just playing by the rules anymore. We're starting to rewrite them. And that is an absolute game changer. And, you guessed it, this new level of control has sparked an incredibly intense global race. This isn't just about scientific curiosity anymore. We're talking about economic dominance, about national security. The data tells a really fascinating story about how this whole competition is playing out. So, who is winning the innovation race? Well, it's not a simple answer. It really depends on what you decide to measure. Is it the sheer number of ideas, or is it their impact? If you're just counting patents, just the sheer volume, the answer is crystal clear. Just look at this chart. China now accounts for a staggering 60% of all quantum patent filings. That's more than triple the United States. It points to a national strategy that's focused on massive scale, just trying to secure intellectual property across the entire quantum landscape. But wait, volume is only one part of the story. If we switch from patents to academic impact, well, the picture completely flips. When you look at the top 10% most cited research papers, the work that's truly pushing the field forward, the US is the undeniable leader with 34%. This suggests we've got two very different strategies at play. China is focusing on the breadth of innovation, while the US is currently leading on its depth and influence. So here's the main takeaway. We have these two competing strategies. China is playing a numbers game, absolutely dominating the patent landscape. But at the same time, the US is focused on producing that really foundational, high-impact research that the rest of the world ends up building on. It's a classic clash, right? Quantity versus quality. And honestly, the winner is far from decided. Of course, all the innovation in the world doesn't mean much without capital to make it a reality. So for our next section, let's do what they always say. Follow the money and see where the private sector is placing its bets. And the investment numbers, well, they're starting to get pretty serious. In 2024 alone, venture capitalists poured $1.6 billion into quantum firms. That is a powerful signal. It tells you that investors are now seeing a clear path from the research lab to the open market. But let's pump the brakes for a second and put that number in perspective. As impressive as it sounds, $1.6 billion is still less than 1% of all global venture funding. So what does that tell us? It says that while the hype is definitely real, we're still in the very early days. The quantum industry is kind of like a sapling in a vast forest of tech investment. And this chart shows you exactly where that early stage money is going. If you look at the last decade or so, from 2012 to 2024, US-based firms have pulled in nearly $5 billion in venture funding. I mean, that just dwarfs everybody else. The UK and Canada have also become major hubs, pulling in almost $3 billion together. So you can see there's a heavy concentration of private investment in North America and the UK. But you know what? Money and patents aren't enough. You also need the right people. And the race for quantum talent is becoming just as fierce. US demand for skilled workers has nearly tripled since just 2018. Building this specialized workforce is now a critical piece of every single national strategy. So, okay, we've got the innovation, we've got the investment, but where is all this headed? What's the next great frontier? It's about connecting these powerful new machines into something even bigger. So, welcome to the wild world of quantum networks. A key report from the National Quantum Initiative Advisory Committee makes one thing super clear. A quantum network isn't going to replace the internet we use for Netflix or scrolling through social media. Nope. Its purpose is way more profound. As this slide shows, it's designed to transmit these incredibly delicate quantum states and distribute entanglement, linking powerful quantum computers and sensors together across huge distances. And that, of course, brings us to the million-dollar question. How on earth do we actually build it? This isn't as simple as just laying down more fiber optic cable. It requires a completely new playbook for R&D, and most importantly, for testing. A huge piece of this puzzle comes down to this thing called a testbed. Now, that term was being thrown around pretty loosely, so an advisory committee stepped in to create a really precise definition. A testbed isn't just a prototype. It's a shared platform for super rigorous, repeatable experiments. It's a place where you can swap out components and protocols to see what actually works in the real world. It's basically where the science gets real. The committee also laid out a clear strategy for building effective testbeds. First, they've got to be right-sized, meaning they should be built with a specific scientific or economic goal in mind, not just for the heck of it. Second, properly timed. You have to wait until the tech is mature enough to actually be tested. And finally, and this might be the most crucial part, you have to involve industry from day one. That way, you're making sure you're building something the real world can actually use. And all of this brings us to the final piece of the puzzle, and it's probably the most important one. This whole technological race isn't happening in a vacuum. It is deeply, deeply connected to national policy, economic rivalry, and of course, global security. The world's major powers are all in on this. The US has its National Quantum Initiative, China has a massive state-led program, the EU has its quantum flagship. But while all their strategies are different, they all face the exact same core problem. How do you balance the open collaboration you need for scientific discovery with the tight security this incredibly powerful new technology demands? This is the central tension that's really defining the quantum era. It's a high-stakes balancing act. As this slide kind of illustrates, innovation pulls you towards openness, but security pulls you towards control. Every major player is walking this tightrope, and the path they choose, that's what's going to define the future of this technology for all of us. So, here we are. We're moving from the purely theoretical to the tangible. The money is flowing, national strategies are in full motion, and the core technologies are finally maturing. The quantum age isn't some distant dream anymore. It's dawning right now. So the only real question left is, who's going to write the rules for this new world?